Alright guys, so this is our first attempt at the flipped classroom model. Excuse me. Flipped classroom model with you guys and pre-cal. Basically the idea is I'm going to teach you the entire lesson for the week, or at least for, in this case, lesson 1.1 with our book, through all the examples. That way when you come to class, if you've got all your examples done, we can work strictly on what would traditionally be homework, but do it in class where you have help, you have someone to guide you. Okay? So the lesson objective for lesson 1.1 is to determine whether or not the given relationship is a function. Okay? The language objective that's on here is more for complete understanding than anything else. If you can verbally define what a domain, a range, a relation, and a function is, you're going to be okay with this section. Now you see 1 through 5. 1, 2, 3, 4, 5. We're going to have one done sometime during Monday's class. So when you're seeing this, you'll already have an idea of what you're needing to do. But 1, 2, 3, 4, and 5, each one of those need to be done, or one of those needs to be done each day. Kind of a warm-up mentally when you come into class. So, since we should have already done this one in class, we'll go ahead and do it real quick. I'm going to work it out over here where I've got some space to work. I'm just going to replace my x values with -2. So it's -2 squared plus 4 times -2 plus 4. Quick work on this would be 4 plus a -8 plus 4. So far so good? Well, +4, +4, -8. Well, that's +8 minus 8. Answer of 0. Now, what I really like about this note model that you're doing, and you're still learning about Cornell notes, is it gives me space while keeping me organized. Okay? So let's go ahead and jump into our first example here. Example you've got here matches, as far as content, the same examples that you have in your book. Different in wording, but overall concept is the same. So this example is oceanography. The table below shows pounds per square inch of pressure that push on a body at various water depths. State the relation of the data as a set of ordered pairs. Also state the domain, range, or also state the domain and range of the relation. So, first thing it wants us to do is state the relation as a set of ordered pairs. So, let's do this right here. I'm going to come over here again. I'm going to use this space. I'm going to say relation. And this relation, I'm going to bracket it real quick. And in parentheses is going to be my first point. So, open parentheses, 0, comma, 14.7. 7, comma, and then I'm going to put another set of parentheses. I'm going to open it up. And the next one in line would be this 16.5 and 22.0. So 16.5, comma, 22.05. Close that. I'm just going to come down here and I'm going to keep going basically down this list. Okay, that's how I'm stating the relation. Alright. For space, we're going to assume that I've already stated all the way down, and I'm going to go ahead and end it with 115.5 and 66.15. So my very last one, come off with a comma, open parentheses, 115.5, comma, 66.15, close parentheses, and then we're going to go ahead and bracket it. Okay? So that's how I'm going to state my relation. Anytime you come up to a problem and ask you to state the relation as ordered pairs, that's how we're going to do it. Okay? Now, as far as stating the domain's a little easier. Okay? We're going to start out the same way with our bracket. Bracket it off, open parentheses, and we're just going to list all of our x values. So 0, comma, 16.5, comma, And we'll go ahead and do the same thing, dot, 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 dot. And we're going to finish with our last x value here, which is going to be 115.5. Then we'll close and bracket to close what's happened. Okay? So now when it asks about the relationship as a range, or all my y values, again, start with a bracket, open it up, open parentheses. This one I'm going to start with 14.7, comma, 22.05. Then I'm going to put all of these right here until I get down to my bottom one, 66.15. So when I finish my last one, it's going to be 66.15, close parentheses, close it off with the bracket. So anytime we come to, again, a problem like example 1, where we need to state the relation as a set of ordered pairs, domain as a set of x values, and then range as a set of y values. Let's get a little more advanced real quick. Example number 2. The domain of a relationship is consecutive, even integers between and including -4 and 4. So the domain of a relation is consecutive integers. That means it's telling you consecutive even integers between and including -4 and 4. So we're going to look at something that occurs from x -4 to x +4 on account of 2. The range y is a relation of the relation is 3 more, let's underline that, 3 more than half of x. So basically we're going to add 3 to half of x, where x is a member of the domain. And where that means basically x survives or exists between -4 and +4. So now we need to write the relation as a table of values and as an equation, then graph the relationship. Alright, let's start with the equation first. The equation is going to be found right here. And we said it's 3 more than half of x. So that would be something along the lines of 1/2 of x plus 3. And if we're doing a y equals mx plus b, y equals 1/2 of x plus 3. That's my equation. Okay? So the graphing calculator, you just plug that in. But Coach Jackson's being mean. I'm not going to give you a graphing calculator to make this easy. Okay? I'm going to make you go ahead and do it out longhand. So as far as my table goes, x points, y points, and it gave you a specific area that it wanted to be covered for x's and y's, and that was from -4 to +4 using consecutive even numbers. So the next even number is -2, then 0, then +2, followed by 4. So now we're just going to plug these numbers in to find out what our y is. -4 goes in, well, half of -4 is -2, -2 plus +3 is -1. Is that right? No, +1, I'm sorry. +1. Then -2 goes in half, that's a -1. -1 plus 3 is 2. 0 goes in, we get 3. 2 goes in, 1 plus 3 is 4. 4 goes in, half of x, or half of 4 is 2. 2 plus 3 is 5. So here are our points, and all we got to do is graph it now. So when you graph this, let's come over here where we've got a little more space. For graphing, give yourself enough room to actually get your graph done, and try to be organized with it as much as you possibly can. So here's my x-axis, here's my y-axis. Now I don't need anything -y. That's why my y negative is so short, because none of these points are negative. So I go to a +1y is going to be a -4x. So 1, 2, 3, we'll call that -4. 1, 2, 3, 4, 5. 1, 2, 3, and 4. So +1y and a -4x. First point. +2y, -2x, Then we've got positive 3 and 0. You can tell my graph's not perfectly straight, but that's alright. Then we have positive 2x to a positive 4y. And then finally, positive 4x to a positive 5y. Yeah. Not a perfect graph, but you get the general idea. If you needed to, or you felt like I couldn't understand this, one thing that you always want to mark is your intercept. In this case, 0, 3. And that lets me know, okay, now I've got a point of reference for grading this. Simple enough? Awesome. Alright, I'm going to switch over. Now you should have got this printout in class. If I didn't give you this printout, yell at me. Okay? But you're going to have to come back and watch notes later time, so that at least that, or you have to write the whole thing down. Hopefully I gave you a printout and you're not having to write the whole thing down. Alright, let's go to example number 3 here. Example number 3, we're going to state the domain and range of each relation. Okay? As it appears to us, domain is x values. If this goes on forever and ever, the x values, basically it appears that all real numbers for x, because we're talking this graph goes on forever this direction, which means it goes forever here and forever here. So my domain, I'm just going to put D, and I'm going to shorthand this. My domain is going to be a negative infinity to a positive infinity. If I was going to put this into words, I would say all real numbers. Make it short and sweet. Okay? Now my range on this particular one, let's see, continuing on forever and ever means it's also continuing on up and down forever and ever, my range. So I'm going to use the same format to show range. Open parentheses, from negative infinity, very bottom of the graph, all the way to positive infinity, very top of the graph, bracketed off. Okay? Not too difficult, pretty easy actually. Going on to this one. This one's a little bit different because it has a relative maximum, right? It can only go so high, and that happens to be where? Well, it happens to be the x-axis, as high as it can go. So as far as we're concerned here, it goes down forever, but it stops going up right there. And because this is opening up, it's going to go here forever and here forever. So my domain, my x values, is also going to be, we'll just do this, all real numbers. But my range, okay, you ready for this? My range is 0 from where it starts and all negative real numbers. So this one, if I was going to write it, I would say it includes, let me bracket this off real quick, as a form of range, it includes 0 and goes to negative infinity. And I can flip that around if I wanted to, however makes it easiest for you guys. Right? But generically, that is what my range is, and kind of the different ways we can write it. Number 4 here, we need to state the domain and range of each relation. Well, and then tell us whether or not it's a function. Domain, all x values, range, all y values. So domain, I'm going to state this real quick. Domain is going to be -1, 0, and 1. And range is going to be 2. Now watch this, 2, 3, then 4. When I state my domain and range, I need to put them in numerical order. So 4 has to go across. Now what we do need to notice to decide whether or not it's a function or not, and not just a relation, is for it to be a function, there needs to be one input to one output. one input to one output. There cannot be multiple outputs to the same input. So when I'm looking at this, one input, different output, one input, different output, one input, different output. Since we're one-to-one on everything, we're going to say yes, this is a relation. Or this is a function. Alright. Now B, same thing. I want you to do B on your own. I think you're pretty intelligent, but I do want you to look at here how the inputs give different outputs. Same input, different output. I'm going to tell you that's going to give us a no. This is not a function. Alright. Jump on down to number 5 here. Our example number 5. Example number 5, we're trying to decide again if it's a function or not. Graphs are really easy. We use something called the vertical line test. If I can draw a line anywhere on the graph, it only hits the point once, it's a function. If it hits twice, it is not a function. So on A, I hit the point twice, not a function. Doesn't pass the vertical line test. Alright? Now if I go to this one, and I draw my vertical line here, I get 1 point. If I come over this way and I draw it right here, I only get 1 point. If I come way over here and I do it, eventually I'm only going to get 1 point. It's going to be down here. So it passed my vertical line test not once, but 3 different times. Passes vertical line test? Yes. Oh, yes. Is a function. Pretty simple. Alright. Alright, so just like we did at the very beginning, we had that first one. Our first problem, number 1. For our warm-up, we were just evaluating each function for its f of x value. In this case, it's f of negative 2 if f of x is 2x to the 4th minus 3x to the 3rd plus 4x minus 1. So basically we're just going to go through, we're going to replace all the x values with negative 2. I'm going to come over here where I've got my extra space to work that one out. So 2, negative 2 to the 4th minus 3 open, negative 2 close to the 3rd plus 4 open, negative 2 minus 1. So first thing I need to do on these is simplify each individual variable, PEMDAS basically. So when I'm doing this, I'm going to simplify this first part right here to 32. It's going to be 32 plus, because we're going to wind up with a negative integer out of here times another integer, another negative integer, which is going to give me a positive 24 plus, it's going to wind up with a negative 8, so let's just put minus 8, and then of course we're going to finish with our minus 1. Final step in this would be to add all that together. Well, 32 plus 24 minus 8 minus 1 is going to give us 47. Somebody check me on math here. If I'm wrong, tell me in class, give you extra credit. Alright, so B, second one here, again we're going to plug in. Well, B is a little bit different because it's an absolute value, right? So regardless of what happens inside of there, our final answer is going to have to be positive. So let's use this space right here to work B. So plug in 3 in for my x value, so the absolute value of 5 minus 3 cubed, absolute value. Well, 3 times 3 times 3 is 27. So we get the absolute value of 5 minus 27. Well, 5 minus 27 is going to give me the absolute value of negative 22. Well, the absolute value of negative 22 is a positive 22. So my final answer here, g of 3 is equal to 22. Simple enough. Alright, guys. Last two examples, you've got number 7 and number 8. And then we're going to talk a little bit about a higher order thinking question, and we'll see how you do. Alright, so number 7, still evaluating. Number 7 is a little bit different because I'm evaluating h of b if h of x. Well, simplistically saying, all I'm going to do is I'm going to rewrite this and replace all the x's with b's. So 3b of 4, or 3b to the 4th power, 2b to the 3rd power, plus b to the 2nd power, minus a b. Pretty simple, right? Now, it gets a little more complicated here in problem B, because we're going j 2a minus 1, or j of 2a minus 1 is the same as j of x, where 2x squared minus 5x plus 1. So when we go to plug this in, we're going to start with 2, open parentheses, this is replacing x, 2a minus 1 squared minus 5, open parentheses, 2a, not 8, a minus 1 plus 5. Well, in order for me to finalize this, I've got to square this and use a little distributive property right there, right? So let's square this part right real quick. 2a times 2a is going to give me 2 times 4a squared, then 2a times a negative 2a plus 2a times a negative 2a is going to give me a negative 4a, and then a negative 1 times a negative 1 is going to give me that final positive 1. Then we're going to have minus a, happy 10a, because we're distributing here and then distributing here, plus, was that 5, plus 1. Alright, let me go through, and on my second step, or my third step, I'm going to distribute right here. So 2a is going to become, or 2 times 4a squared is going to become 8a squared minus 8a plus 2 minus 10a plus 5 plus 1. I'm sorry, this 1 should have been inside. I mixed it up right there. That's alright. Now I'm going to combine all my like terms. That's 5 plus 1 plus 2. It's going to give me 8 plus, that's positive, negative 10a and a negative 8a is going to give me a negative 18a, and then a squared, that's the only a squared I have, so it's going to be 8a squared for a final answer. Okay? Alright, example number 8. State the domain of each function. How do I state